All right, well, so I want to keep talking about C. And we left off yesterday talking about command line arguments, and I want to continue to explore that. So when we write a main program, we can specify two arguments to main, an integer and a char star star. And we broke these down yesterday, and we decided that argc was the number of things you put on the command line, and argv was an array of strings, okay, which represented the things that you put on the command line. So if we want to look at that, we can make sort of our standard for loop. So I'm just going to make a big print statement. I'm going to say argv bracket, and I'll print the value of I. And I'll say equals, and I'll print the value of argv element I. And I'm going to put that in angle brackets because I like delimiting things to see what's at the end of them. Is it a space or not? And I'm just going to print that in a for loop. And that'll be the end of my main program. So I can compile that up. And so if I just say main 3, it tells me argc is 1, and that first argument is main 3, right? Name of the program. I say this is fun, argc is 4, right? And nothing too weird going on there. And there's no real limit to how many arguments you can have until you run out of memory. So here's the thing. If I say main 3 12, it tells me my first argument is 12. Yes?
So then it's not that, if you wanted to just print everything but main 3, you do the same exact loop, but just have it start at 1.
Sure, start from 1 and it'll just print the actual arguments. Good. All right, so argv bracket 1 is 12. So let's write this program that takes a number as a command line argument, doubles it, and prints it out. Okay, so I'm going to come over here. I'm going to comment out all of this stuff. And I'm just turning all of that into one big long comment, so I don't actually delete it, so it's still there if I want to go back and refer to it. So here's what I want to do. Double argv bracket 1 and print it out. So this is something like what I would try in bash, right? I'd say take that argument, multiply by 2. I'd have to do $paren stuff, store the result in answer, and then just print out answer. And this will not work in C, right? So I can try to do this. And when I compile, I get a big red error message. It says invalid operands to binary star, have an integer and a character star. And what it's complaining about is that this star is a multiplication operation. It takes 2 operands. They should both be integers, and it's got an integer, which is the 2, but then it's also got a char star, which is argv bracket 1, because argv bracket 1 is not an integer. Even though it looks like an integer, even though when I ran it, it said it's equal to 1, 2, it's a string. Okay, it's a set of characters that happen to look like a number to us, but it's not a number. It's just a string. And in C, you cannot multiply a string by an integer. It doesn't know how to do that. So what we have to do is tell C first to convert this string into an actual bona fide integer. Any ideas or guesses how to do that? So you've used the function Scanf, right? To read numbers from the input. Well, there's a better function called Sscanf. And that's like Scanf, but it applies to a string. And so Sscanf has the following structure. You can have some sort of array or buffer of characters, some sort of format specifier, same thing you do with Scanf, and then some sort of place where you want to store the thing that was scanned. So I use the word buffer a lot. And I was talking to someone the other day, she was a student a few years ago, and she was saying that she never knew what a buffer was. And it drove her crazy, and her friend finally was like, we're not going to use the word buffer anymore, we're going to say elephant. And any time that they were looking at their notes, they replaced elephant for the word buffer. So don't let buffer trip you up, okay? Buffer is just a word I use for, it's just a variable name, okay? It's an array of characters in this case. So this is an array of characters. That we want to convert. %d is how we want to convert. So our array of characters might be like a 1 followed by a 2 followed by an all terminator. How we want to convert, %d means we want to do an integer. And this last argument is where to store the result. So a lot like Scanf, except we've got this extra thing in the front, because we're converting from a string, not from standard in. So let's convert this to an integer called num. So I'm going to say integer num, and I'm going to say Scanf argv bracket 1 %d and address of num. And now we're going to double the number, so we'll multiply by 2, store the result and answer, and then we'll print out what that final answer is. And then we'll just return. So now if I say main 312, prints out 24. Yeah.
Where's the exclamation GC?
Where's the what? Oh, that's pulling back my last command that started with a GC.
Oh.
And it's easier than typing it in over and over.
That is easier.
We'll spend an afternoon going through shell tricks one of these days soon. You can also up arrow to get the previous commands. All right, so good so far? So I'm going to post all of this code on Canvas. Okay, I'll open a link there later on, and it'll point to an area on the server, and you can click through and you'll be able to get all this code. So you can download it and play with it. All right, so there's one problem still with this program, which is if I say main3 ha ha ha, it's going to try to convert ha 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 to an integer and then double that, and it's going to give me some crazy number. And if I do this again, it's going to give me a different crazy number. And in fact, chances are every time I do this, I'll get a different crazy number. And we'd kind of like to know if that's going to happen and be able to do something about it. So, the issue is, if we don't have an actual integer inside this buffer, Scanf doesn't know how to convert it. So that crazy number is not really so crazy. If I initialize num to 1, 2, 3, 4, 5, and I run main3 haha, whoa, it did recompile. Well, that's strange. Oh, it's doubling it. Right, so if I say main3 ha ha ha, it's taking 1, 2, 3, 4, 5 and doubling that, right? And Scanf is apparently always converting my number to 1, 2, 3, 4, 5, which was the value I initialized to. So what's happening? Scanf is not storing a crazy number in here. Scanf is completely ignoring this. And what it's doing is it's saying, okay, here's the thing I'm trying to convert, ha ha ha. I want to convert it as an integer. Ha 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 is not an integer, and it gives up. And it never touches this variable. So if Scanf can't convert something and store it in a variable, it doesn't try. It leaves the variable unchanged. So we could put something in here which says if your number is 1, 2, 3, 4, 5, print out, hey, you don't know what an integer is. You're not very smart. But of course the problem is we might actually want to use the number 1, 2, 3, 4, 5, and now our code's insulting us for no reason. So we need a better way to know if Scanf succeeds or fails. So here's the way to use Scanf. So we use Scanf, some buffer, some format specifier, and an output variable. This function returns a value. And you always want to save that value or look at it. So let's print out what the result of Scanf is. So we'll just throw in a diagnostic print statement, right? After Scanf comes back, we'll print out the value that it returned. So if I say main312, it tells me the return value from Scanf was 1. If I say main3 haha, it tells me the return value from Scanf was 0. And if I say main3 with an empty argument, it tells me the return value from Scanf was -1. So there's lots of different possible return values. So here's how we interpret the return value from Scanf. This is the number of variables over here written by Scanf. The return value is the number of variables that it updated. And if it's the same value that's in there, that's still updating it, right? So it's the number of these things that it loaded up as a result of converting your string. So in this particular statement, we're asking it to convert one integer and load the value into this variable. So the only indication of success is Scanf returns a 1. So our condition should be if it's equal to 1, success, else failure. And that's subtle but important. Don't start saying if it's equal to 0, it's failure. Okay? Because it could be -1 and fail also. So if it's equal to 1, it's success. If it's not equal to 1, it's a failure. And that's the only comparison you should do. Yeah.
Is it possible to have higher than 1?
Yes. So suppose we have an Scanf. Some buffer. %D, %C, %F, %D. And we're storing into 4 variables. A, B, C, D. So this is trying to convert 4 things, an integer, a character, a float, and an integer. If it finds all 4 of those things and stores them into A, B, C, D, this will return a 4. If it can only convert the first 2 because this thing's not a floating point number, it'll return a 2. So how do you check if this function succeeded in what you were trying to ask it to do? See if it returned exactly 4. And if not, then you may want to say, okay, if it returned 3, then here's what's going on, and so on and so forth. Okay, but generally we take the return value and say, is it equal to however many things we put in this conversion, right? However many variables we named. So we can adjust this code pretty easily now. So let's comment this out. So if result is not equal to 1, there is a problem with the input. So what are we doing now? We're saying take the result from Scanf, see if it's equal to 1. If it's not equal to 1, I'm going to print out an error message. And my error message is going to be inside angle brackets, whatever you specified as argv bracket 1, I'm going to say that is not a valid integer, and then I'm just going to return. And I'm returning a 2 so that if somebody cares outside, right, they can actually see that this program failed. Otherwise, we'll take the number we converted, multiply by 2, print it out, and return a 0. So if I say main 312, doubles it, prints out 24. And if I check the return status, it's a 0, because I'm saying return 0. If I say main 3, haha, tells me haha is not a valid integer. And if I check the return status, it's non-zero, it's a 2. And when I wrote the documentation for this program, I would say, you know, return value 0 upon success, 2 if the argument is not a valid integer. And then somebody could take this and put it in their bash script, call main 3, and then check $* and say if it's equal to 2, do whatever you want to do, ask for another try or whatever. And even if I give it an empty argument, right, it'll still tell me it's not a valid integer because it didn't succeed in converting. If I give it too many arguments, what's it going to do? Is it going to work or not? Raise your hand if it's going to work. Raise your hand if it's going to blow up and the universe is going to collapse. Probably, hopefully not. Okay, we're still here, right? Because I didn't test for that condition. I just said take the first argument. Could I pick up this condition and somehow say, hey, that's not how you're supposed to use it? How would I do that? A little easier than that. Check argc, right? I know that if I have one argument, main 3 space number, argc should be 2. So I could put another check in here which says if argc is not equal to 2, then, you know, get out of here. But if I run this without an argument, I get the saddest of all sad faces, a segmentation fault. So why did I get a seg fault? So what is argc if I run just main 3 without any arguments? Argc is equal to 1, right? Because it counts the program name. And something we mentioned yesterday is that if argc is 1, we should only check the first element of argv. And here I'm using argv bracket 1, that's the second element of the array. And we're not supposed to access argv beyond the first argc elements. And that's a condition we do want to check for. I'm not too worried if they put in extra stuff, but I really don't want a seg fault, right? So we'd probably want to put an extra check in here. And I'm going to say before we do anything with argv bracket 1, make sure argc is at least 2. And if argc is 1, don't try to do anything with argv bracket 1, because argv bracket 1 is null. And when you try to scan it or print it, it's going to give you a problem. So if argc is less than 2, the user didn't enter a number, error must specify a number on the command line. And I'll do a return code of 7 for that particular error condition. And I'm going to exit my program before I come down here and do scanf on argv1. If I don't return from there, it's going to give me an error message, and then it's going to give me a seg fault. Got 2 error messages. So now if I run main3, it says error must specify a number. But if I specify a number, it does that. If I specify a non-number, it says it's not an integer. And I could put another statement over here and say if argc is bigger than 2, print an error saying you can't have more than 1 argument. And then we got a pretty solid piece of code. But you get the idea, right? Okay, so Scanf is the thing that converts a string using the same thing we do with scanf.
Something to mention, when you just type in main3,
Mm-hmm.
previously we should do // main3. How did you do that?
So, yeah, we do have to spend a day talking about tricks, don't we?
Just another trick.
So I thought I set that up on everyone's accounts, though. Has anybody tried this without a // just executing a program by typing its name instead of // does that work? Okay, so there's a variable that's already set up for you called path, uppercase, and it lists all the places where it's going to look, where bash is going to look for a file. If you just type in blah and it doesn't know what blah is, it's going to look for a file named blah. But it doesn't search the entire system, it only searches a few directories. These are the directories it searches in. Okay, so on this system I added another directory in the very beginning, which is period, and period is a shortcut for your current directory. So it'll always look in dot. And when you say / blah, you're saying go to directory dot and look for a file named blah. That's your current directory. So that just saves you from having to do that. All right, so here's the next piece of the puzzle. This works great for command line arguments, right? But what if you, yeah?
What'd you say Scanf was essentially?
So Scanf is the same as Scanf, except it converts from a string instead of from standard in.
Okay.
So we can take a command line argument, we can use Scanf, convert it to an integer. But the other thing we want to do is we want to actually read a program input. We want your program running, we want to wait for the user to type something, take what they typed, convert it to an integer. And that you've probably used Scanf for. Right? And this reads from the keyboard, converts to an integer. And after today, I'm going to say do not use Scanf. Okay, avoid it. And here's the reason. Yes?
So if you don't provide a buffer, it will read from the keyboard, but
If you use Scanf, it'll read from the keyboard. And Scanf does not take a first argument of a buffer. If you use Scanf, you got to specify a buffer, and it reads from that, and it never reads from the keyboard. All right, so here's the deal with Scanf. Scanf is doing two things for you. It's doing input, right? It's reading from usually your keyboard, whatever standard in is, and then it's doing parsing or converting. So Scanf does two functions that are totally different from each other. The first is reading characters from your keyboard, and then the second is saying, let's convert those characters into an integer. And I'm going to tell you how you can break those two functions into separate pieces of code. Okay? Parsing and converting, we're going to use Sscanf. So that's, parsing. How do we just read a set of input from the keyboard and store it in a character array? Do you remember the function for that? Starts with an F. F gets. Good. So if we take these two functions and we put them together, fgets will read from standard in, will read from the keyboard, and store what it reads into a character array. And then Sscanf will let us take that character array and parse it, convert it into some other format. And one advantage of this is we don't always know what the right format is. Sometimes the user's going to type a number, sometimes they're going to type a letter. And both of those may be legal. And the way we can tell what they've done is by trying to convert with different Scanf patterns. But if we use Scanf, that's inputting and parsing. Once we input, that input is gone, right? So split it up into two pieces. First do your input, then do your Scanf. And now I can do this, 20 different ways on the same input that I got from this one fgets, and I'm going to get exactly what I want. So avoid Scanf, right? The other problem with Scanf is it's got some security issues. If you don't use this just the right way, you can get vulnerabilities in your code. So, are you familiar with gets? Which also reads from standard in. Do you know anything in particular about the gets function?
You have no idea how much is being input.
You have no idea how much is being input. So this you definitely want to avoid. Absolutely. Okay, this one people get really paranoid about. If you stumble during an interview and you write a piece of code that uses gets, they'll probably end the interview. Okay, people are like really freaked out about the gets function. Look at the manual page for gets, right? First line of the description, never use this function. Okay, it was in the early versions of C. And it's a great function. It works well as long as you're in complete control of the input and you're not trying to do something nefarious. But there's no limit on how many characters gets will try to store in buffer. So you set up buffer to hold 100 characters, and somebody starts typing an input and they type in 1,000,000 characters. Where are most of those 1,000,000 characters going to go? Somewhere outside of buffer. Right? And if they're really good and they know your system, they can load those characters in just the right way to, for example, change some password flag from a 0 to 1, and now the system thinks you've been authorized through a password. Right? So that's a buffer overrun exploit. So we avoid gets and we use fgets. So how does fgets work? It takes 3 arguments. Thanks. So first argument is the buffer that you want to load your input into. Second argument is the length of that buffer. That's the big secret. And then the third argument is where you want to read from, and for us it's almost always standard in, which usually means keyboard. And if you type more than 120 characters, no harm done. The first 120 will get loaded into buffer, and it won't overrun. All right, some more junk code. Print out a prompt, I'll say enter something. I'm not printing a new line at the end, so after the colon, it's just gonna kind of sit there and I'm gonna start typing after the colon, so it'll look a little cooler. I'll take whatever you type in, and I'll use fgets, right, to load that into buffer up to 120 characters, and then I'm gonna print it out. So this is just test code. So I run main for, enter something, hello Nick, and it says buffer equals hello Nick. And what do we notice that's a little weird there? Yeah, the angle bracket came out on a new line. And that's a feature. When you hit enter, that's registered by the system as this new line character, this \n, and that's part of the input. Okay, now that's different from gets also. Gets dumps the new line. fgets keeps it. That's okay. But it's just something to be aware of. Now, if I do a buffer overrun, let's say my buffer is only 5 bytes long, and I type in something longer than 5, not a problem. So it only stored the first 4 characters in my buffer, but I told it the buffer had 5 bytes. How come it didn't store HELLO?
The null byte indicating the industry.
Got to have the null terminator at the end. So if you want the person to be able to type in 5 characters, you got to let fgets read 6. And you got to have your buffer read 6. All right, the other thing is, suppose I tell it to read 120 characters into buffer, but buffer is only set up to hold 5 characters. Is that okay? Smashed your stack. So fortunately, modern C compilers build in checks to detect if we're trying to load something beyond the end of that space. All right, so it knows buffer only has space for 5 characters, but fgets, I told it to load up to 120 characters in there, and I typed in something longer than 5, and so it started trying to fill up buffer, but it got to the end of that region of buffer and it said, hey, you're trying to go beyond here, can't do that. So it gave me an error message and it quit the program on me. Not all systems do that. Some systems will just blindly start filling in memory with the text. So if you do this, make sure that if you say buffer can be 120 characters, that it's actually at least 120. I could make it bigger, I could make it 1,000 and just use the first 120, that's fine. Make sure you got enough space. So let's convert this to an integer. So I'll make an integer num, I'll call Scanf on buffer, %d and num, and I'll store the result in result. I'll print out the result. Now let's go ahead and double the number. Yeah. We'll just print out the number. All right, so I'll print out the return value from Scanf, and then I'll print out the number. I don't know if these things are. Is that okay to see up there, or is it just hard for me to see it?
Yeah, it's fine.
Fine, okay. I think it's just my angle. So main for, enter something. I'll type into 12. The result of Scanf was 1, and the number was equal to 12. And if I type in ha, it tells me the return from Scanf was 0. And I should not have done anything with number at that point. Right, I should have picked up that 0 and said, oh, we don't actually have a number that the user input. And then just go on from there. And if I just hit an enter, Scanf returns a -1. And the number is still 0. So again, did it succeed in converting an integer? See if result is equal to 1. Right? First case it was, that was success. These other cases is different from 1, that means failure. All right, questions up to here? So let's talk a little bit about this business of standard in. So that's our argument. It's the last argument to fgets. What is standard in? Anybody?
What's your common form of getting input and output, input output? That's your input output.
That's the input side of the input output, right? So where does standard in usually come from?
Keyboard.
Comes from the keyboard, right? So here's kind of the mental image I have of standard in. It's this end of a pipe, okay? And stuff goes into this end of the pipe, and it flows through, and it comes out, and where it comes out, that's what we call standard in. And when we say fgets buffer 120 standard in and print that out, let's do that twice. Let's do it 3 times. And let's exit right there. So we're going to enter something, we're going to call fgets, print it out, fgets, print it out, fgets, print it out. And we're reading from standard in, right? So I'll run main 4, and I'll say hello there, and it prints out hello there. And now it's sitting here and it's waiting for me to type something else. So I'll say ha ha ha, and it's still waiting for me, so I'll type in my password, and our program's done. Okay, so let me change this a little. And let's make buffer really small. So buffer, I'm saying, is only 4 bytes, so it can load 3 characters and a null terminator. And I'll type in, hello, this is a test, bye. You remember what it did last time, right? So here's what it does this time. A little different from what we might have expected. But here's what's happening. Normally, your keyboard is connected to this end of the pipe. Oh, that was such a cool picture too. Normally your keyboard is connected to the input side of this pipe. So you type, 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 and you hit enter, and everything that you typed goes into here. So HELLO, this is, and so on. When you call fgets and you say read 3 characters from standard in, it says, okay, I'll take an H and an E and an L. And those get pulled out of the pipe and they go into your buffer, but all this other stuff is still sitting inside this pipeline. And the next time you call fgets, it picks up 3 more characters, and all this other stuff is still sitting in the pipeline. Until it gets to a new line. And if it gets to a new line, even if the buffer isn't filled up, it says, okay, I'm done reading things from standard in for now. So fgets reads up to a new line, right, which it includes, or it reads until it's read as many characters as you said it was allowed to read.
Is there a way to clear the pipe? Or-
There is, but we don't usually. But you can flush it. So if we type this big long string, right, that doesn't fit in the buffer, the first time we call fgets, it picked up the first 3 characters. But then when we called fgets again, it didn't wait for me to type more stuff because it already has stuff in this pipeline. All right, so the cool thing, one of the cool things about Linux is we can take other things and feed them into the top of this pipeline. And this is going to be a whole section of discussion at some point. But let me modify this a little. So let's just go back to a basic thing. Read from standard in, print it out. So if I say hello Nick, it says buffer equals hello Nick. So we can do something in Linux called a pipe. We can actually say execute some command, and then we can make a pipe symbol, a vertical bar, and list a second command. And what this says is go ahead and run command 2, but instead of having standard in be the keyboard, have it be the output of command 1. So it takes the output of command 1 and it sends that to the input of command 2. So what does that mean? Well, here's a command called who. It shows me who's logged into the system. Here's a command main4, it reads from standard in and it prints it out. I can say who, pipe that into main4, and now main4 thinks that I typed in Nick PTS/0, etc., etc., and that's its input. Or I can take the date command, which shows me the current date and time, and pipe that into main4, and it says buffer equals Thursday, October 4th. The other thing I can do, I can make, say again? Yes, exactly. The output of command 1. So I can also make a file. So here's a file. It's got 3 lines. It says this is a file, haha, bye. And I can run main4, but I can say, instead of taking standard in from the keyboard, take it from a file. So this is called input redirection. And now it reads the first line of the file, and that's what it's taking from standard in. So we'll spend about a week playing with these, okay, using pipes to connect commands together and using input redirection to read from a file instead of standard in. And that's tip of the iceberg. There's a whole world underneath that, and it really unlocks the power of being in a Linux environment. Because now we can start chaining commands together in all kinds of crazy ways, and it just gives you a way to take the few tools that you learn and put them together and get these really rich combinations. So that's a preview. We'll play with that in a lot of detail, probably next week. We'll see. Okay, so tomorrow we will go over PA2, and I will end class early tomorrow because I'll have to go set up for my talk. So it'll be probably about a 35 minute class tomorrow. All right, so I'll see you next time.